Tucked into the western edge of the Pyrenees, in a strip of land that straddles the border between France and Spain, there's a population that has been quietly breaking the rules of European history for over a century. Their language belongs to no known family on Earth. Their blood carries a genetic marker at a frequency found nowhere else on the continent. And when scientists finally got the tools to test what made them different, the answer wasn't a foreign origin, a lost migration, or a hidden bloodline from somewhere exotic. It was something stranger. They hadn't come from anywhere else. Everyone else had changed around them. This is the story of the Basque people, and why modern genetics says they may be the closest thing Europe has to a living fossil. Let's start with the part of this mystery that has nothing to do with DNA at all, because it's what put linguists on alert 100 years before geneticists ever got involved. Nearly every language spoken in Europe today can be traced back to a single root: French, German, Russian, Greek, Norwegian, Hindi. Despite sounding nothing alike, all of them descend from a language called Proto-Indo-European, spoken somewhere on the Eurasian steppe thousands of years ago. That single ancestral tongue splintered, spread, and eventually became the entire linguistic map of a continent stretching from Ireland to India. Except in one place. Euskara, the Basque language, doesn't fit anywhere on that family tree. It isn't a distant cousin of the Indo-European languages. It isn't related to anything. Linguists have spent centuries trying to find its relatives and have come up empty every single time. No sister language, living or dead. No ancestral branch it split from. It sits alone, a linguistic island in the middle of a continent, where almost everything else can be traced back to one shared root. The specifics only make it stranger. The Romans occupied Basque territory for centuries, and virtually every language they touched absorbed heavy Latin influence. Spanish, French, Italian, Portuguese, Romanian, all fundamentally Latin in their bones. Euskara didn't. It shows almost no meaningful Latin borrowing, as if the Romans simply washed over it without leaving a mark. Its number system counts in base 20 instead of base 10, a structure that suggests it developed its own internal logic in isolation, disconnected from the counting systems used across the rest of the ancient world. And some of its most basic vocabulary, words for stone, for water, for knife, are structurally so simple that some linguists consider them candidates for the oldest surviving words in any spoken language on Earth. For most of the 20th century, this was treated as a fascinating curiosity and not much else. A linguistic oddity, tucked away in the mountains, interesting to specialists, and largely irrelevant to everyone else. Then, in the 1940s, doctors started drawing blood. Medical researchers screening blood types across Europe noticed something odd about Basque populations almost by accident. The Rh-negative blood factor, the same one that matters for blood transfusions and pregnancy compatibility, showed up in Basque communities at a rate far beyond anywhere else on the continent. Some communities tested as high as 45 to 50% Rh negative. The average across the rest of Europe sits at roughly 15%. Nowhere else came close. Here's why that mattered more than a quirky statistic. Rh negative frequency isn't a trait that stays elevated by accident. When populations mix and intermarry over generations, unusual blood type frequencies get diluted. They drift toward whatever the surrounding regional average is. That's just how gene flow works. For the Basque rate to stay this dramatically elevated century after century, something had to be actively preventing that dilution. Either this was a population that had barely mixed with its neighbors for an extraordinarily long time, or it had arrived from somewhere with an unusual genetic profile and then sealed itself off before it could blend in. Two theories took shape, and neither one could be proven. The first said the Basques were the last surviving descendants of the hunter-gatherers who lived in Europe before farming ever arrived, a population that had simply never been absorbed by the waves of newcomers that followed. The second said they'd migrated in from somewhere unknown entirely, carrying an unfamiliar genetic signature with them, and become isolated only after they'd already settled. Both were plausible. neither had the evidence to close the case. For the better part of a century, the Basques stayed exactly what they'd always been, a population everyone had a theory about and nobody could actually confirm. Then ancient DNA sequencing became a real scientific tool, and the entire debate got resolved almost overnight, just not in the direction most researchers were expecting. In 2021, a team led by geneticist David Comas at Pompeu Fabra University in Barcelona ran the most detailed genetic study of Basque ancestry ever attempted. They didn't just sample the general population, they specifically selected around 200 individuals whose 4 grandparents had all been born in the same tightly defined microregion, to filter out any recent population mixing from the modern era. They screened over 600,000 genetic markers per person, and compared the results against nearly 2,000 individuals from across Europe and the Mediterranean. What they found ruled out the exotic migration theory completely. There was no mystery outside ancestry, no hidden founder population arriving from somewhere unexpected. What the data showed instead was continuity, an almost unbroken genetic through line stretching back roughly 2,500 years to the Iron Age. Here's the detail that made researchers sit up. Basque genetic profiles pulled from Iron Age burial sites are strikingly close to the genetic profiles of Basque people living today. Compare that to the rest of the Iberian Peninsula, where the average population has been reshaped by wave after wave of incoming ancestry. Romans, Visigoths, North African Moors, Phoenician traders, and more, until a modern Spaniard's DNA carries traceable contributions from at least half a dozen distinct historical populations. The Basques absorbed almost none of it. While the genetic map of the entire peninsula was being rewritten around them, they simply stayed put, genetically speaking, almost frozen in place. Comas himself described the pattern as without real precedent anywhere else on the continent. That's not a casual statement from a geneticist. That's someone who studies population genetics for a living, telling you they haven't seen anything else quite like it. The Basques weren't migrants who'd wandered in from somewhere unusual. They were, in the most literal sense, the original population. Still there, still largely unchanged. The mystery had flipped entirely. It was never about where they'd come from. It was about how, surrounded by 3,000 years of migration and conquest, they'd managed to stay so completely themselves. That finding alone would have been enough to rewrite the textbook entry. But when the researchers dug deeper into the internal structure of the Basque genetic data, they found something even more specific, and it pointed to a mechanism nobody had seriously considered. The obvious explanation for genetic isolation is geography. Mountains keep people apart. The Pyrenees are real, rugged, and difficult to cross. So surely that's the answer, right? Not quite. The Pyrenees are formidable, but they're not impassable. They never have been. Trade routes ran through them for millennia. Armies crossed them repeatedly throughout history. Plenty of populations elsewhere in the world have lived behind far more extreme natural barriers and still ended up thoroughly mixed with their neighbors within a handful of centuries. Geography alone doesn't explain isolation this extreme and this durable. What the genetic data actually showed was a correlation nobody expected to be this precise. The strength of Basque genetic isolation tracked almost exactly with where Euskara was spoken. Communities where the language had been continuously used for generations showed the tightest genetic isolation. Areas where Euskara had once been spoken, but gradually died out, showed a measurable blurring, more mixing, more shared ancestry with surrounding Spanish and French populations, and regions where Euskara had never taken hold at all looked genetically like everywhere else in the region. The boundary of the language and the boundary of the genetics were, for all practical purposes, the same line. It goes further than that. Different dialects of Euskara corresponded to distinct genetic subclusters within the broader Basque population. Researchers found they could predict with real accuracy which dialect a person's ancestors likely spoke, just from their DNA profile alone, even when comparing communities separated by no more than 15 or 20 kilometers. That's a level of genetic differentiation you'd normally expect between populations on opposite ends of a continent, not between two villages a short drive apart. Take the Roncal Valley in Navarre, a small community of shepherds speaking their own distinct dialect of Euskara, whose genetic signature has remained remarkably stable for over 1,000 years. Marriage records from the 1500s show that the overwhelming majority of people in that valley married within their own dialect group, not just within the broader Basque population, but within that one specific linguistic community. Euskara wasn't a side effect of Basque isolation. The evidence increasingly points to it being the actual mechanism that produced it, a linguistic wall that quietly did the work geography gets credited for. Step back from the fine detail for a second, because the bigger picture here is worth sitting with. Europe's genetic history, viewed as a whole, looks something like a document that's been overwritten again and again. The first farmers arriving from Anatolia displaced the original hunter-gatherer populations. Steppe herders swept in during the Bronze Age and reshaped the ancestry of nearly the entire continent. Then came the Romans, the Germanic migrations, the Slavic expansions, the long churn of medieval movement. Each layer partially erased the one beneath it. What most Europeans carry today is a genetic composite built from all of that overwriting, the original text almost entirely lost beneath everything written on top of it. Almost entirely. Geneticists have a term for a population that escapes most of that overwriting, a genetic refuge. A group that absorbed so little of the successive migrations reshaping everyone around them that their genome still reflects, in measurable ways, what Europe looked like before most of that overwriting even began. When researchers compare modern Basque DNA to ancient European samples that predate the big Bronze Age population shifts, the resemblance is closer than for almost any other living European population. In a very real, testable sense, Basque ancestry offers a window into a version of Europe that exists nowhere else, not in any other living population, anywhere on the continent. The cultural record backs this up from an entirely different angle. Basque inheritance customs historically kept property within single-family lines and discouraged marrying outward. Basque women held property rights and social autonomy that were unusually strong for medieval Europe, which meant they were choosing to marry within their own communities, not being married off to outside families for political or economic advantage. Basque mythology preserves goddess-centered traditions that predate any Indo-European religious framework layered on top of them later. None of this is folklore trivia. It's a second, independent line of evidence, and it points in exactly the same direction as the genetics. Here's the part of this story that stayed with me the longest. The mountains didn't do this. That's the tidy, comfortable explanation, and the evidence just doesn't support it. Plenty of populations elsewhere in the world lived behind more extreme natural barriers and still ended up genetically transformed within a few centuries. Mountains slow armies down. They don't stop trade, ideas, or the slow cultural pull of neighboring communities generation after generation. Something else was operating here, and what the evidence points to is closer to sustained collective choice than geographic accident. A community that, generation after generation, chose to keep marrying within the language, to keep passing property through the same family lines, to keep teaching the language to children even during periods when it would have been considerably easier to let it fade and blend in with everyone else. The language was the mechanism, but the language itself had to be actively renewed, over and over, by people who kept deciding it was worth the effort. That has implications well beyond this one population. It suggests that cultural identity, maintained deliberately across generations, can outlast almost any physical barrier. That intention, sustained long enough, can do what mountains and rivers can't. There's a practical payoff to all of this too. Because Basque populations represent such an unusually unmixed genetic baseline, they've become genuinely valuable to researchers studying the genetics of certain diseases, a kind of natural control group, uncomplicated by centuries of population mixing that make disentangling genetic risk factors difficult almost everywhere else in Europe. What looked for decades like a scientific curiosity has turned into an actual research resource. And that genetic thread runs directly into the present, into people living in Bilbao, in Bayonne, in San Sebastian today, carrying something ancient and unbroken in their biology. A measurable, testable connection to a version of Europe that doesn't survive anywhere else. Not a metaphor, not a folk story, an actual documented biological fact. The DNA didn't dissolve the mystery of the Basques. If anything, it confirmed the mystery was real all along. What genetics actually delivered wasn't a simple answer. It was proof that a population can remain measurably, continuously itself across 2,500 years of pressure, conquest, and transformation happening on every side of them. Not through isolation by accident, through choosing, generation after generation, not to disappear into everyone else. That's what makes them worth talking about. Not that they survived. Plenty of populations survive in some diluted, half-remembered form. It's that they survived intact, still speaking a language related to nothing else on Earth. Still, in the most literal sense possible, themselves.